Hello everyone, this is Chinnaiah Kalpana here. In this video we are going to solve a Legender's equation. So let's get going. Problem: solve 2x plus 5 whole square into d square y by dx square minus 6 times 2x plus 5 into dy by dx plus 8y equal to 6x. Solution. So the given differential is of Legender's form. See, the Legender's equation is ax plus b power n into, that Legender's equation is of the form ax plus b whole power n into d power n y by dx power n plus p1 into ax plus b power n minus 1 d power n minus 1 y by dx power n minus 1 plus so on plus pn equal to some function of x. Okay, so here we are given a differential equation of order 2, okay, which is of Legender's form. So we are given a Legender's equation. Two x plus 5 whole square into d square y by dx square minus 6 times 2x plus 5 into dy by dx plus 8y equal to 6x. Consider as equation number 1. We can write d square y by dx square as d square y minus 6 times 2x plus 5 into, we can write dy by dx as dy plus 8y equal to 6x. Now take y common from all the three terms of LHS. We'll get 2x plus 5 whole square into d square minus 6 times 2x plus 5 into d plus 8 into y equal to 6x. Right? Consider as equation number 2. So now we are going to solve this equation by reducing it to a linear differential equation with constant equations using some substitution. Okay. From Legender's equation method, we know that ax plus b can be replaced by e power z. Then z equal to log of ax plus b. And theta is a differential operator whose independent variable is z, and ax plus b into d can be replaced by, here you are having power 1, right? So you will have only one term of theta into coefficient of x, ax plus b whole square into d square can be replaced by, here you are having square, right? So you will have two terms of theta, theta into theta minus 1 and coefficient of a square. Coefficient of x, a square. So you'll get a square into theta of theta minus 1. And ax plus b whole cube into d cube can be replaced by, since we are having cube. So you'll have 3 terms of theta into coefficient of x, a cube. Okay. Fine. Now coming to our problem. Let 2x plus 5 equal to e power z, then z equal to log of 2x plus 5. Here also theta is a differential operator whose independent variable is z, and here 2x plus 5 into d can be replaced by, here you are having power 1, right? So you'll have only one term of theta into coefficient of x, 2, which is 2 theta, and 2x plus 5 whole square into d square can be replaced by, here you are having squares, right? So you'll have 2 terms of theta and coefficient of x, 2 square, which gives us 2 square, 4 theta into theta minus 1. Okay. Now let's replace 2x plus 5 whole square d square by 4 times theta into theta minus 1 and 2x plus 5 into d by 2 theta, and we'll replace x in terms of z. We'll see that. Now this equation becomes, equation 2 becomes 2x plus 5 whole square into d square can be replaced by 4 theta into theta minus 1 minus 6 into 2x plus 5 into d can be replaced by 2 theta plus 8 into y equal to 6. You have to replace this x, right? Since you are having 2x plus 5 equal to e power z, from this just take this 5 to RHS, then you'll get 2x equal to e power z minus 5. From this you'll get x equal to e power z minus 5 by 2, right? Since x equal to e power z minus 5 by 2, so you can just replace this x by e power z minus 5 by 2. This becomes 4 theta into theta, 4 theta square minus 4 theta into 1, 4 theta minus 6 2s are 12 theta plus 8 into y equal to 3 times e power z minus 5, right? Now this gives us 4 theta square minus 4 theta minus 12 theta gives minus 16 theta plus 8 into y equal to 3 times e power z minus 5. Now we can take 4 common from all these 3 terms, right? So let's take 4 common. You get 4 times theta square minus 4 theta plus 2 into y equal to 3 times e power z minus 5. Now take this 4 to RHS, then you'll get theta square minus 4 theta plus 2 into y equal to 3 by 4 into e power z minus 5. Consider as equation number 3, which is an operator form f of theta into y equal to some function of z. I'll call it as r, the RHS part of the reduced equation. See, we have reduced the given differential equation to a differential equation with constant quotients, right? And also it is an operator form f of theta into y equal to r, where f of theta is theta square minus 4 theta plus 2 and r equal to 3 by 4 e power z minus 5. Now we'll find the general solution to this equation using y equal to yc plus yp, where yc is a complementary function, yp is a particular integral, and using the general solution of equation 3 we'll find the general solution of equation 1. The general solution of equation 3 is the results in terms of z, and the general solution of equation 1 results in terms of x. Okay, let's see that. Now we can find yc using auxiliary equation and yp using 1 by f of theta into r. Okay, now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of theta, theta square minus 4 theta plus 2, right? Let's replace theta by m in f of theta, so that we'll get f of m equal to m square minus 4m plus 2. Then the auxiliary equation becomes m square minus 4m plus 2 equal to 0, right? Now we need to find roots to this equation, so let's use quadratic formula to find roots to this equation. Minus b plus or minus square root of b square minus 4ac by 2a. Just compare this equation with am square plus bm plus c, the quadratic equation, so that you'll get the values of a, b and c. A equal to 1, b equal to minus 4, c equal to 2. Now substitute the values in this formula. We'll get minus of minus 4 plus or minus square root of minus 4 whole square minus 4 into 1 into 2 by 2 into 1, which gives us minus into minus plus 4 plus or minus square root of minus 4 whole square 16 minus 4 to the 8 by 2, which gives us 4 plus or minus square root of 16 minus 8 is 8 by 2. You can write square root of 8 as 4 into 2. Now split the square root as square root of 4 into square root of 2. Since we know the square root of 4 is 2, right? Now take 2 common from these two terms, I mean the terms of in numerator, then you'll get 2 times 2 plus or minus square root of 2 by 2, where 2 gets cancelled, and we'll get 2 plus or minus square root 2. Okay, conjugate irrational roots. Therefore, m equal to 2 plus or minus square root of 2, a pair of conjugate irrational roots. So we got roots to our auxiliary equation. Let's write the complementary function using these roots. When m equal to a plus or minus square root of b, yc will be e power az into c1 cos h z root b plus c2 sin h z root b. Okay, here z is our variable, so we are writing z instead of x. Okay, fine. Now just compare these two and write yc. You'll get yc equal to e power 2z into c1 cos h z root 2 plus c2 sin h z root 2. So this is a complementary function. Now we need to find yp, or you can write this as root 2z. c1 cos h root 2 into z plus c2 sin h root 2 into z. Okay, now coming to yp. Yp is given by 1 by f of theta into r. We have f of theta, theta square minus 4 theta plus 2 into r is 3 times e power z minus 5, right? So we can write this as 3 into 1 by f of theta, theta square minus 4 theta plus 2 into e power z minus 5. Then yp equal to 3 times 1 by theta square minus 4 theta plus 2 into e power z minus 1 by theta square minus 4 theta plus 2 into 5. So this is of 1 by f of theta into some constant type, right? The second fraction. So we can write the constant as k into e power 0 z form. Okay, since this is a 1 by f of theta into k type, so what we'll do is we can just write this as 1 by f of theta into k into e power 0 z, since e power 0 z equal to e power 0. Since e power 0 equal to 1, so we'll get 1, right? So k into e power 0 z becomes k into 1, which is again k. Okay, so we'll write this 5 as 5 into e power 0 z in the next step. This becomes yp equal to 3 into 1 by f of theta, theta square minus 4 theta plus 2 into e power z minus 1 by f of theta, theta square minus 4 theta plus 2 into 5 into e power 0 z. Then yp becomes 3 into 1 by theta square minus 4 theta plus 2 into e power z minus 5 into, we can just write 5 beside, towards left. Theta square minus 4 theta plus 2 into e power 0 z. Okay. Here, the first term is of 1 by f of theta into e power az type, and this of, this part is of, also is of 1 by f of theta into e power az type, right? Let's solve these two separately for our convenience. So I'll begin with the first term, 1 by theta square minus 4 theta plus 2 into e power z. So here we are having f of theta equal to theta square minus 4 theta plus 2, right? So now we need to find f of 1. Coefficient of x is 1. Just compare this with 1 by f of theta into e power az. Then for a equal to 1, we need to find f of a, that is f of 1. Okay, just replace theta by 1 here. We'll get 1 square minus 4 into 1 plus 2, which gives us 1 minus 4 plus 2, which gives us 1 plus 2, 3 minus 4 is minus 1, which is not equal to 0. Since f of 1 is not equal to 0, so we'll just replace this theta by 1. So we'll get 1 square minus 4 into 1 plus 2 into e power z, which gives us 1 by 1 minus 4 plus 2 into e power z, which gives us 1 by minus 1 into e power z, which gives us minus e power z, right? So the result obtained from the first term is minus e power z. Now coming to the second one. See, by replacing theta by 1, the denominator becomes non-zero. So that we are replacing theta by 1. Okay. If you get 0 by replacing theta by 1, then we'll not substitute theta equal to 1. Okay. Fine. Now coming to the second one. The denominator must be always non-zero. One by theta square minus 4 theta plus 2 into e power 0 z. So just compare this with 1 by f of theta into e power az. Then for a equal to 0, we need to find f of a, that is f of 0. Just replace theta by 0, you'll get 0 minus 4 into 0 plus 2, which gives us 2, right? Which is non-zero. Since by replacing theta by 0, the denominator is non-zero, so we can substitute theta equal to 0, right? Since f of 0 is not equal to 0, so we are going to replace theta by 0. You'll get 0 minus 4 into 0 plus 2 into e power 0 z, which gives us 1 by 0 minus 0 plus 2 into e power 0 z, which is equals to 1 by 2 into e power 0 z. Again, e power 0 z is 1, right? Since e power 0 z equal to e power 0, and we know that e power 0 equal to 1, so e power 0 equal to 1. So finally, you'll get e power 0 z equal to 1. Just replace this e power 0 z by 1, you'll get 1 by 2 into 1, which is 1 by 2. So the result obtained from the term under brackets is 1 by 2. Now coming to yp, 3 into, result obtained from the first term is minus e power z minus 5 into, result obtained from the term under brackets is 1 by 2, which gives us minus 3 e power z Okay, it's 3 into, right? Fine. Minus 3 e power z minus 3 5s are 15 into 2. I mean into 1 by 2 is 15 by 2. Or you can just write this as minus 3 into, just take 3 common and write it as, simply you will take minus 3 common, okay? Or just take minus common from these two terms. Fine, already you are having 3 here, so you'll get minus 3 into e power z plus 5 into 1 by 2, 5 by 2. Okay, either you can write minus 3 into e power z minus 15 by 2 or minus 3 into e power z plus 5 by 2. I'll prefer the first one. Therefore, yp equal to minus 3 e power z minus 15 by 2 or minus 3 into e power z plus 5 by 2. Right? We got yc and yp. Let's now find the general solution to equation 3, which is given by y equal to yc plus yp. Therefore, the general solution to equation 3 is given by y equal to yc plus yp. Then y equal to yc e power 2z into c1 cos h into square root of 2 into z plus c2 sin h into square root of 2 into z plus yp. You can consider either first one or the second one, okay? It's up to you. So I'm taking the first one. Okay, see, we got the solution in terms of z. Therefore, y equal to e power 2z into c1 cos h into root 2 into z plus c2 sin h into root 2 into z minus 3 e power z minus 15 by 2 is the required solution to equation 3. Now using this solution, we can find the general solution to the given equation. Okay. So if you wish to take the second one, you'll just get e power z plus, okay, fine. Now we have y equal to e power 2z into c1 cos h root 2z plus c2 sin h root 2z minus 3 e power z minus 15 by 2 or y equal to e power 2z c1 cos h root 2z plus c2 sin h root 2z minus 3 into e power z plus 5 by 2, right? Since e power z equal to 2x plus 5 and z equal to log of 2x plus 5. So by replacing e power z by 2x plus 5 and z by log of 2x plus 5, we'll get the solution in terms of z, which is the required solution to the given differential equation. Okay. In order to replace e power z by 2x plus 2x plus 5, we'll write this e power 2z as e power z whole square, so that it will be easy for us to replace e power z by 2x plus 5. Okay, so I'll just change it here itself, or you can write in the next step. Better I'll write in the next step. I'm writing e power 2z as e power z whole square into the remaining terms will be as it is Again here e power 2z can be written as e power z whole square. Right? Now it will be easy to replace e power z by 2x plus 5. Let's see that. Replace e power z by 2x plus 5 and z by log of 2x plus 5. Then y equal to, you're having e power z, right? So replace it with 2x plus 5. You'll get 2x plus 5 whole square into c1 cos h root 2. Replaces z by log of 2x plus 5 plus c2 sin h into root 2 z. Replace z by log of 2x plus 5. Okay. Minus 3 into, replace e power z by 2x plus 5 minus 15 by 2, or y equal to 2x plus 5 whole square into c1 cos h root 2 into z log of 2x plus 5 plus c2 sin h into root 2 log of 2x plus 5, right, minus 3 into, replace e power z by 2x plus 5 plus 5 by 2. So this completes the problem, which is the required solution to our problem, or the general solution to the given differential equation, which results in terms of x. Well, we have seen a problem from Legender's equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.